Welcome back to 3 Inquisitive Kids. Here is problem 2. Right triangle ABC has AB, which is equal to 5, BC is equal to 12, and CA is equal to 13. Point D lies on the angle bisector of angle BAC such that CD is parallel to AB. Compute the length of BD. Pause the video to see if you can solve the problem on your own. Let's reread the problem and mark everything we know from the information it has given us. ABC is a right triangle. AB is equal to 5, BC is equal to 12, and CA is equal to 13. Point D lies on the angle bisector of BAC. Therefore, angle CAD and angle BAD are equivalent. What is the length of BD? So what is this length here? Well, as you can see, if we move over to this side, CB, over to the right, we are given a segment with the exact same length that is perpendicular to BA. So if we just connected this over here and extended it, we would get a side length of 12 and a right angle. And we're trying to find the hypotenuse of this right triangle here. So we could call this, let's call this X. What else do we need in order to find the length of the hypotenuse? Well, we need to know the measure of the other side, which let's call this A. If this is A and we created a rectangle, then CD is equal to A as well. So now how can we solve for A? Well, if we look at the A on the top here, we see that it is part of a triangle, CAD. Actually, I'll use a different color, CAD. It is part of this triangle here. And what is interesting about this triangle? Well, first we know that, let's call this point E, we know that quadrilateral BCDE is rectangle. So if we know that this is a rectangle, it means that opposite sides must be parallel. So CD is parallel to BE or AE. And using our alternate interior angle theorem, alternate interior angles, and this is a very important theorem when it comes to proving two parallel lines. This is a property of parallel lines that always exists, and if you're not sure what it is, tell us in the comments down below if you would like us to make a separate video on that, because that is something we are very open to doing. But because we know this theorem, alternate interior angles, we know that the two alternate interior angles of this parallel set have to be equal. They have to be congruent. And you'll see that if we just also take a look at AB here, which is also parallel to CD, we will see that we have, let's call this angle 1. Angle 1 will have to be the same as this angle here, so we'll also call it angle 1. Because of the alternate interior angle theorem, we know that these two angles have to be the same, since CD and AB are parallel. Now again, because this angle 1 is the same as this one over here, and at the same time, we know this angle measures the same, let's call this angle 1 as well. So we know that they are all the same measure. Because we see two angle 1s on this triangle, we know that triangle CAD is isosceles. Triangle CAD is isosceles. And because CA and CD are part of this isosceles triangle, A must equal 13. Now we have found out A. All we have to do now is use the Pythagorean theorem to find X. X is equal to the square root of 13 squared plus 12 squared, which is equal to 169 plus 144, which is equal to the square root of 313. So the final answer is 313.